All right, the next one's going to be on Chapter 9, Part 1. We're going to divide Chapter 9 up into 3 parts. So this will be the first part. This is going to be on law of sines, law of cosines, dealing with the beginning of your trig functions. So the first question is cosine of 7/9, and you're given a picture. So it's a right triangle, not any particular quadrant. We deal with that later. So the cosine would be the adjacent over the hypotenuse, making the missing side 81 minus 49, which is 32. So the square root of 32 is 4 square roots of 2. So now, doing the rest of the trig functions, sine is opposite over hypotenuse, tangent opposite over adjacent. Secant is the opposite of cosine, so we got 9/7. Cosecant is the opposite of sine, which gets a little bit more challenging. So now we end up getting 9 over 4 square roots of 2. This is this one right here. Multiply both top and bottom by the square root of 2. So I get 9 square roots of 2 over 8. And then the last one's cotangent 7 square roots of 2. I probably should show my work. Sorry about this. So we have 7 over 4 square roots of 2. Multiply both top and bottom by the square root of 2. And so there's the last one there. Next one. Find the value of x and y in the following special right triangles. You're going to need to know 30, 60, 90, and 45, 45, 90 triangles. 1, 1, square root of 2 is the ratio. So in this particular picture, opposite of 45 is x, opposite the other 45 is y, or 5, sorry, and the hypotenuse is y. Setting up a proportion, 1 over x, 1 over 5, and cross multiply to solve. 1 over 5, square root of 2 over y, and cross multiply to solve. Another 45, 45, 90. So we end up getting 1, 1, square root of 2. Opposite of 145 is x, opposite of the other 45 is y, and the hypotenuse is 7. So we end up getting 1 over x equals square root of 2 over 7. This is where things start getting a little bit more interesting because you have to divide by the square root of 2, just like you did on the previous question. You end up have to multiply both the top and the bottom by the square root of 2. And now setting up the exact same proportion here, 1 over y would equal the square root of 2 over 7, and you're actually going to get the exact same answer then without me going through all the work for that one. Now we got a 30, 60, 90 triangle. So a new ratio that we have to memorize. Opposite of 30 is x, opposite of 60 is 3 in this question, and the hypotenuse is y. Square root of 3 over 3 equals 1 over x. Cross multiply and divide. So now I got to rationalize. So I get 3 square roots of 3 over 3, which actually ends up being just the square root of 3. And the next one, I get 2 over y equals the square root of 3 over 3. So I end up getting the square root of 3 equals 6, dividing by the square root of 3. So I get 6 square roots of 3 over 3, and running out of space, reducing that, y is 2 square roots of 3. I'll try to give myself more space this time. 30, 60, 90 triangles is a 1 square root of 3, 2. Opposite the 30 of this picture is 7. Opposite the 60 in this picture is y, and the hypotenuse is x. 1 over 7 equals 2 over x. This one ends up being pretty good. Cross multiply and solve. 1 over 7 square root of 3 over y. Again, cross multiply to solve. Now, what happens if it's not a 30, 60, 90 triangles? Notice it's telling you to round all answers to the nearest tenth. And so you are given an angle. You are given, it's a right triangle. This is right triangle trig only. Are you allowed to use SOHCAHTOA? Okay, it has to be a right triangle in order to use this. So now, in this particular triangle, you are given the opposite side and the hypotenuse. So the sine of 32 equals x over 13. Now, multiplying both sides by 13 in order to solve the equation. Pulling out a calculator now. Make sure you're in degrees mode, by the way. That is a common mistake a lot of times on these types of questions, is not being in degrees mode. And so then 13 times the sine of 32 is 6.9. Next one, again, using SOHCAHTOA. This time we're going to use cosine. Cosine of 55 equals adjacent over hypotenuse. Multiply both sides by x. And then doing a little bit of algebra skills here, we're going to divide both sides by the cosine of 55. And so x would equal 34.9. Tangent this time. Tangent of x equals opposite over adjacent. Now I'm asking for the angle measure. So if I ever want to get the angle measure, instead of actually finding, I'm going to take the inverse tan of both sides. Using a calculator now, set inverse tangent of 12/7, you get 59.7 degrees. Again, we're trying to find the angle measure. This time we're going to do sine because it's opposite over hypotenuse. Inverse or arc sine of both sides. And using your calculator, inverse sine of 5/11 is 27 degrees. Area. You're going to need to know your area formulas. These will not be given to you. So area is equal to half AB sine C. So if you know two sides and the angle in between, you can find the area. So half 12 times 10 times the sine of 53. Using your calculator now, typing that in, you get 47.9, and it's in centimeters. So 47.9 centimeters squared. Another area formula that you would need to know is Heron's formula. This will not be given to you. But you need to do A plus B plus C divided by 2, and then the area equals square root of S, S minus A, S minus B, and S minus C. So now, in this particular question, S is equal to 6 plus 9 plus 11 divided by 2. So S in this particular question is 13. So now, using a calculator to find the area, S minus A, and I'll show my work here, 13 minus 6, 13 minus 9, and 13 minus 11. And so taking that into account, you get 26.98, and it's in feet squared. Law sines and law cosines. You will not be given the law sines or the law cosines. You will need to know them. In this particular case, anytime you're given one, I would recommend you draw a picture. You're given angle A is 25 degrees, side A is 15, and side C is 18. If you ever have a ratio in which the side and the side opposite, okay, you can use the law of sines. Now, this is a red flag. First one we have is also one that we have to worry about. If you have an acute angle and the opposite side is smaller than the adjacent side, this is a double case. We're going to need two pictures for this one. But let's get started. Sine of 25 over 15 equals the sine of C over 18. Cross multiply to solve. So I'm going to end up with 18 times the sine of 25 equals 15 times the sine of C. Divide by 15. So that will give me sine of C. Then take the inverse sine, and C would equal 30.5 degrees. Now, this is the one that we have to worry about. If C is 30.5, then angle C in our second picture, and I realize we're going to run out of space here, but angle C in our second picture will always be the supplement. So that makes angle C in the second picture 149.5 degrees. So here we go. We got two pictures going, and angle C in the second picture is 149.5. Now I'm going to do the rest of the picture separate. So if angle C in the first picture, we'll call this picture 1 and picture 2. If C in the first picture is 30.5, that means angle B is 124.5. And then I can do sine of angle B over little b equals, and I'm going to do the one that I'm given, so sine of 25 over 15. I ran out of space here, but side B is 29.3. And then down here, angle B would need to be 5.5 degrees. And then sine of 5.5 over B would equal the sine of, again, I'm going to do the given, so 25 over 15. Side B equals 3.4. So this is by far the hardest one that we'll actually be doing today, okay, in which you'll have two cases. When will you have two cases? When you have an angle that's acute and the side opposite that is smaller than the side adjacent. Next one, again, I'm going to draw a picture. This time I won't draw my picture quite so big. Angle A, angle B, angle C, and you are given that angle C is 75, side A is 5, and side B is 7. So you cannot use the law of sines. You have no ratio. You don't have an angle with the side opposite, but you can use the law of cosines. C squared equals a squared plus b squared minus 2ab cosine c, and that is not going to be given to you. So in this particular question, c squared equals 7 squared plus 5 squared minus 2 times 5 times 7 times cosine of 75 degrees. Using a calculator, c squared equals 55.8. and C would equal 7.5. Once you know that angle, or that, excuse me, that side is 7.5, now I can use the law of sines again. Sine of 75 over 7.5 equals, and we're going to do sine of, sine of 5. Let me try this again. Sine of B over 7. 7 times the sine of 75 equals 7.5 sine of B. Divide by 7.5. Take the inverse sine. B is 40.1, which means angle C, which you don't know yet, is 64.9 degrees. Again, draw yourself a little picture. Angle A, angle B, and angle C. C is 118. Side C is 10. Side A is 4. So here's the things I don't know. I don't know angle B, I don't know angle A, and I don't know side B. But sine of 118 over 10 would equal the sine of A over 4. Cross multiply and divide. And again, 4 times the sine of 118 divided by 10. Arc sine or inverse sine on both sides, you get A to be 20.7 degrees. So over here, 20.7 degrees. Then if A is 20.7, I can find angle B. All the angles inside of a triangle need to add up to 180. So 118 plus 20.7. The last angle would be 41.3. And then the last thing I would need to do is sine of 41.3 over B. Sine of 118 over 10 again. Cross multiply and solve. I end up getting B to be 7.5. Next one. Again, draw yourself a picture. Now, this is probably the one that causes most people problems. Anytime you're doing the law of sines, you always want to go with the smallest angle. Anytime you're doing the law of cosines, you always want to go with the biggest angle. So the biggest angle in this picture is C. So if I did law of cosines now again, because you can't use the law of sines, you have no ratios, 17 squared equals 8 squared plus 15 squared minus 2 times 8 times 15 cosine C. Now, the hardest part about this is you must subtract these two first and then divide by these two. And I know I didn't show all my work here, but you end up getting C to be 107.4. Next, once I know that C is 107.4, now I can go back and do the law of sines. Sine of 107.4 over 19 equals the sine of A over 8. Cross multiply, solve. A is 23.7, and then the last angle then is 48.9 degrees. That concludes part 1 of our chapter 9, dealing with law of sines, law of cosines, area formulas, SOHCAHTOA, right triangle trig. If you have any questions on any of those type of questions, please make sure to talk to Mr. Bone or Mr. Smith.